Okay, so I am going to discuss another two problems of special relativity came in this CSIR NET 2024 exam. Okay, so this is the first problem. The problem says that delta double plus can be produced by colliding a pion beam onto a H2 target. The reaction can be viewed as that pion plus proton is delta double plus, and it can be viewed in another way that delta double plus is producing pion and proton. So the question is, in the rest frame of delta double plus, the energy and momentum for the final state of pion in MeV. So, and it is given that C is equal to 1, mass of pion is 140 MeV, mass of proton is 1 GeV, and mass of delta double plus is 1.2 GeV. So, yeah, so we have to do everything in the rest frame of delta double plus. So, we can first write the conservation of momentum equation. So, in the rest frame of delta double plus, the momentum of delta double plus is 0, that is P delta double plus is 0, it is at rest. And from momentum conservation, we can say that initial momentum is final momentum. So the momentum of delta double plus is equal to momentum of pion plus momentum of proton. That is P of delta double plus is equal to P pi plus P of P. That is P of momentum of proton, and that is equal to 0. So P of pi is equal to minus P of P. So we can see that this proton and pion have same magnitude of momentum going in two different directions. So we can think that this has a magnitude of P. Now we can use the conservation of energy equation, that is initial energy is final energy. So the initial energy of the delta double plus is only rest mass energy because it has no momentum. We are in the rest frame of delta double plus, so it has rest mass energy of 1.2 GeV is equal to the energy of pion plus the energy of proton. So what is the energy of pion? It is root under p pi a square c square. C is equal to 1 plus m pi square c to the power 4. Again c is equal to 1. So it is simply root under p pi square plus m pi square. Similarly for proton, it is root under ppa square plus mpa square. So mp and m pi already are given. M pi is 0.14 and mp is 1. So now we can rearrange this algebraic equation and do square on both sides, and after doing a little bit algebra we can simply find that the momentum of pion, that is P, is 130 MeV per c square, and the energy of pion, that is root under p square plus m pi square, that is mass of pi square, that is equal to 191.5, that is almost is equal to 190 MeV. So in this case, option 4 will be the correct option. Yeah. So another problem from special relativity. This is actually a simple problem to do in exam. So we have a square plate. The length of the plates are a. Makes an angle theta is pi by 4 with the x-axis in its rest frame as shown in the figure. So these two angles, this theta are pi by 4, and the interior angle phi is pi by 2. So it is moving with a speed v is equal to root under 2 by 3 c along x-axis with respect to observer s prime. So we have to calculate that what is the value of the interior angle phi. So initially phi is pi by 2 for square, and we have to calculate what is the value of phi in the rest in the frame s prime. So here is the frame S prime, and in the frame S, let us suppose the rod is as angle theta. If you don't remember the formula directly, you can derive it very quickly, assuming this picture that if a rod is an angle theta, then what is the contracted length in the S prime frame? So the contracted length in the S prime frame is Lx prime, that is horizontal component, that is x component only changed, so y component remains same. So the contracted x component of length Lx prime is Lx by gamma, and similarly Ly prime, it is not changed, Ly prime is Ly. So the angle viewed by observer S prime, that is theta prime, it can be related at tan theta prime is equal to Ly prime by Lx prime, that is equal to gamma Ly by Lx is equal to gamma tan theta. So this is the relation of the angles from of the observer S and of the observer S prime. So we can now directly put the value of gamma and tan theta. We have gamma is 1 by root under 1 minus v square by c square. So v square by c square is 2 by 3, and theta is pi by 4. So we can find that tan theta prime is root 3 and theta prime is 60 degree. So this angle, this theta is changed, theta is equal to pi by 4 is actually changed to theta prime is equal to pi by 3 for the observer S prime. So this angle, this pi by 4 is also changed by 60 degree, and this angle also changed by 60 degree. So what is the interior angle now? What is phi prime? Phi prime is equal to pi. The total angle is pi minus 2 into theta prime. That is 2 into pi by 3. So pi minus 2 pi by 3 is equal to pi by 3. So from the for the observer S prime, the interior angle of the square will be 2 pi minus 2 pi by 3 is equal to pi by 3. So option 1 will be the correct option for this problem. So thank you. If you have any doubt or any comment, please let us know.